Hi guys. Not sure why. There might be some filter. Okay, so now it's okay. So today I don't feel very good today. Yesterday I didn't feel very good. Today is also similar. But I'm trying to solve some medium question problem with a high acceptance rate, but reasonably high frequency rate. So let's try to find nested list weight sum. This is premium question. So let's try this next one. So 82% is pretty high. All passes from source to target. Okay, let's first listen to the problem.
Given a directed acyclic graph, DAG, of n nodes labeled from 0 to n1, find all possible paths from node 0 to node n1 and return them in any order. The graph is given as follows. Graph I is a list.
Okay, so they directed acyclic graph. So this is such graph. It's like a okay, so this one should return 0, 1, 3 and 0, 2, 3, right? 0, 1, 3, 0, 2, 3. Then this one 0, 1, 4 and nowhere to go. 0, 4, 0, 3, 1, 0, 3, 4, 0, 1, 3, 4, 0, 1, 2, 3, 4. Something like that. And then graph I is a list of all nodes you can visit from node I. Okay. So from 0, the vector will contain this one and this one, like this. So there is no cycle. There's gotta be some end point, end node, and then I wonder what's gonna be the starting point. From node 0. So node 0 is kind of root node. Okay. So this is something like a depth first search problem. So from here, actually, it's some kind. It can be represented some kind of tree, right? Right. So from traversal, the way it is traversal is a little bit different. Less, but so this DFS. Well, the complexity of DFS and BFS will be similar. In case of BFS, we need some kind of queue where we store all the queue and then pop this queue. So the space complexity is, but we don't know how many, so the depth, the all node inside the depth is the, is not that one, but in case when a graph is skewed like this guy need to store this one when graph is like this. We have stored this one, so time complexity, the worst is almost O of n in case of BFS. And then we have to visit all node, so the time complexity is almost O of n in case of tree, but since this is not tree, it will be more than this, because one node is pointed by multiple nodes, so which means that there's some duplicated visit. So in case of depth first search, so what's gonna be the alpha is related to the number of edge, if there are many edge. Let's think about this later. In case of DFS, well, as always, in this case, we have to store everything inside the Q stack, call stack. So space complexity is O of n, and the time complexity is also depends on the number of edge. So for example, like this 1, 2, and then 1, right? So, and then if something like this, 1, 2, 3, 4, 5, 6, 7, 8. It's kind of hard to calculate. I can't solve this right now, but the time complexity is similar between DFS and BFS. So we're gonna send the graph. And then let's say that let's make a result which is empty at the first time. So graph, and then result, so and then starting point 0, root index, so if graph root index size equals 0, like shown in here, Okay, in that case I need to just return. If otherwise for int k so here how to build the result is, so from here 0 we'll have a 0, we'll do these two for the next round, next call, but at the moment, so we'll have 0, 2 and 0, 1, right? And then after that, so for this guy, for example, this guy will have 0 and then 3, 0, 1, 3, 0, 1, 2, 3, but not this one, right? So after passing this one, this guy add 4 to the end of this vector, right? But we don't want to make one of the interesting is, in case of this one, we have 1, 0. And this guy has 2 paths. So 1, 0 should be 1, 0, 3 and 1, 0, 2. So how to represent this? One way is to pass the previous result. If the previous result is 1, then the next result we're gonna duplicate. We're gonna clone the previous result and then attach these two. Or this guy, or this guy weights the result of this guy and result of this guy, and then attach 1. So this guy, so if we have one more here, so this guy will attach the result. In case of this guy, from here, this guy will have 4 and something 4. So what will be better? In latter case, each one need to return vector, list of vector. And In the former case, each one you to construct vector and then pass it to the next vector. And the thing is 0, 1 is constructed by 1, and this one will pass 0, 1 duplicate 0, 1 and 0, 1 to this guy and this guy. And at the end of and then the terminal node like 4, this guy will have all the, when it does not have any node to go, then it will copy that node into the result. But this time let's do this like this. Okay. Okay. Oh, sorry. One way to do this is you can insert this next index but this may take long time, always adding something at the end, at the front takes some time. So let's just add to the end and then let's reverse that later. Auto VV is this one. So what I'm thinking is that we can do some so VV dot for each, and then we can have some vector int V so this is stood. So what am I doing? What? So we have VV, VK, that, and plates back. Next index. So from here, we'll get the next one, and then get the VB. So if this is 4, then this will be empty, right? So we're gonna add 4 here. So what if the only input node is 0? So in the case 0, so 0, so this one is 1. So this one is not empty, and then so root node is 0. Let's say that what I'm curious is who's the one adding this 4 in case of when the root node is 4. This means that I'm gonna add myself, right? So here what it in case of 3, this will give you 4, right? 4. So you have 4, then please include myself. Okay. So the test and this is the and okay, so when this is the input, when this is input, it needs to return 0. So initially it's 0, so 0, and then the size is 0, right? So it will return 0. In this case, this means that graph is this one. So here 0, so this is not true, so 0, that size is actually 2, so it will loop 2 times, so 0, 0, 0, so this is 1, next index is 1, and then it will be 2, right? So we're gonna add 1 here, and then it will return some kind of VV. So which means that something from 2 will be returned, so it's gonna add something like this, and then then any case we need when we need to duplicate, so 0, and then 0, and then 1, and then 2, 3. So in the case, first thing is 0, and then DFS will return some vector, right? Which I don't know, we don't know. So next item is now 1. So we pass 1 here, and then in case of 1, it has 2 nodes. This one, and then the next one, right? So the thing is, after we get this, interesting. So we need to return answer, and then answer dot in place back we add this, and then we're gonna start gonna add this one. One thing I don't like is that copy in copying operation occurs many times. So we need to reduce the copying operation. But let's run this. Accept it. Oh, wrong answer. Zero, 1, 3, 4, 1, 3 to 4, 3, 2, 4, and then 3 is 2 is this. And then 3 goes to 4. So 1, 0, 1, 2. Isn't this correct? 0 has passed to 1, and the 1 has passed to 2, and 2 is the last node. So there is passed to 0, 1, 2. But expected does not have 0, 1, 2. Why? Two. Maybe I understand the question in the wrong way. 1, 3 to 4, 3 to 4, and then 2 is last node, then 3 goes to 4. So 0, 1, 3, 4. Yeah, right. 0, 1, 4. Yeah. 0, 3, 4. 0, 3, 4. And 0, 4. And 0, 1, 2. Why it does not have 0, 1, 2? What's the problem? Given a directory of cyclic graph of n node labeled from 0 to n minus 1, find all possible paths from 0 to node n minus 1. So this is So which means that okay, we went to 0, 1, 2. Then 2 is not the right end. 4 should be the right end, right? So in the case, what should we do? We already so the thing is, what's n? Graph size -1. Yeah, in that case, we can do this. But what's the else? What's the else? If so, the thing is, in this code, we add many things here. So even though we return, one way to do this is that we tell his parent, tell his caller that, oh, this is not the right way, right? So one thing we can do is do things like wrong terminal. So here this must be 0 to something. No. Not I. Yeah. So we can return -1. So here, if wrong terminal, can I do this? Right? If this is a wrong terminal, we're not gonna add that into the answer. What? Two, 0 goes to 2, and then 1 goes to anywhere. Did I run this? And then, okay. Okay, 0 goes to 2, 1 goes to nowhere, and 2 goes to 1. In that case, 1, 2 is the answer? Really? How come the acceptance rate of this question is this high? This is so many, missing cases, corner cases. So 0 to -1. Find all the possible paths from 0 to node minus and return them in any order. Oh. So in this case, there is no way for 1 to point to 2. You can just stop, right? Last index is graph dot size because this is size t. Constant value last index by a constant expression? Oh, really? Okay. So this is the last index. So if this is last index, so actually this is not important. What is important is this one. And then if this is empty, then so else you don't need else. So when it's not, everybody knows, and somehow this is the end, then we got wrong terminal, otherwise we do this. And terrible. Both are really terrible. 6 millisec. Yes, I have to fix this. But in the meantime, okay, let me rewrite this by myself later, okay? Okay, so this is it. Where is the bye.